This is R.D. Sharma solution class 12 chapter 13 derivatives as a rate measure. Exercise is 13.2. The side of a square sheet is increasing. Now square means the shape where all the sides or edges are equal. So it is increasing at the rate of 4 cm per minute. So this is a rate. Rate is always, when it is not given, always with respect to time. The denominator will always be time. At what rate is the area increasing when the side is 8 cm long? So there is a rate of increasing, there is a rate of decreasing. That rate, that is the elongation or increasingness with respect to time, we have to find out. So formula we already have. The question is also saying area increasing, that we need to find out. Area is side square. Here we are taking side as x because we always take x when we are dealing with derivative. So area increasing, the side of the square sheet is increasing. So what is the side? We have taken x as the side. Okay. So this side dx by dt. If x is the side, dx by dt is given as 4 cm per minute, and that also this 4 cm per minute infer that you have to take dx by dt. Alright, so 4 cm per minute it is, and area is still x square, but we haven't found out the rate of increasing of area. That can only be computed when we take dA by dt. So dA by dt is a differentiation of x square, which is 2x, but we are differentiating with respect to t, not x. So we have to introduce, or we have to differentiate x and write it as dx by dt 2, and then we have this dx by dt already being given in the question, 4 cm per minute. X is what? When the side is 8 cm long, so we put 8 in the place of x. 2 into 8 into 4 is 64, and centimeter, it's centimeter, then minute, so centimeter square by minute. The minute is also, the unit are also very important. An edge of a variable cube is increasing at a rate of 3 cm per second. So 3 cm per second, edge of a variable cube. So there is a cube, but it is varying. It may be increasing, it may be decreasing. But cube is a shape, is a three-dimensional shape where all the side, all the edges are similar, equal. How fast is the volume of the cube increasing when the edge is 10 cm long? What is the volume of the cube? It's x cube here, because we are taking x as the side or the edge of the cube. Now edge of the variable cube is increasing, so d, if you take x as the edge, so dx by dt is given in the question, which is 3 cm per second. This is already given. So dx by dt, you can write it separately somewhere, since you can write, as I've given you the reference also of the solution. The dx by dt is 3 cm per second. How fast is the volume of the cube increasing? So volume increasing or decreasing means dv by dt we have to find out. But we have to find out dv by dt, but on the right we have only x. So we have to differentiate x cubed, which is 3x square. And differentiation of x also we have to do dx by dt, because we are differentiating with respect to t, not x. So what is the dx by dt? Already given in the question, 3 cm per second. And what about this side? It is saying edge is 10 cm long. When the edge is 10 cm long, so you have to put 10 square here. So when you do 10 square, it will be 100. 3 into 3 is 9. It is going to be 900 centimeter cube. Why? Because centimeter square into centimeter is going to give you centimeter cube, and centimeter cube, since it is already having a second in the denominator, it is going to be 900 centimeter cube per second. Alright, so this is dv by dt we have found out. The side of a square is increasing at the rate of 0.2 centimeter per second, 0.2 centimeters per second. Find the rate of increase of the perimeter of a square. Square, all sides equal. Area, we already seen. Perimeter, 4a, 4x. If you take the side of a square as x, then 4a or 4x, because we always take x, so 4a is the perimeter. So you just write perimeter as 4x, and since the rate of increase of the perimeter have to be found out, dp by dt we have to find out, and since this side of the square is increasing at the rate of 0.2 centimeter per second, dx by dt is already given in the question, which is 0.2 centimeter per second. So dp by dt we have to find out. On the right there is no t, so you have to introduce dx by dt. At that place you are going to replace 0.02. So dp by dt, differentiation of 4x is 4, x differentiation is 1 only, and then dx by dt also to be introduced. Dx by dt is given as 0.2. So it will be 4 into 0.2 centimeter per second, that is going to be 0.8 centimeter per second. This is your dp by dt, which is the rate of increase of perimeter of the square. If you make the diagram, it will be very, lucrative for the examiner. He will give or she will give good marks. What is the rate of increase of its circumference? The radius of the circle is increasing at the rate of 0.7 centimeter per second. Now circumference is 2 pi r. Just write C as 2 pi r. Rate of increase, that is dc by dt, we have to find out. dc by dt, whenever there is a rate, always remember there will be a time in the denominator when in the differential. Radius of the circle is increasing at the rate of 0.7 centimeter per second. That is dr by dt is already given as 0.7 centimeter per second. Now dc by dt we have to differentiate. Means C we have to differentiate. dc by dt is going to be 2 pi dr by dt. There is no see, this is r and you are differentiating with respect to t, not anything. There is no x, there is no r. Dr by dt, but dr by dt is already given in the question, which is 0.7. Just provide it here, 2 into pi into 0.7. You can just write it as 1.4 pi centimeter per second, but pi you can write as 22 by 7 also. When you write 22 by 7, because this 0.7 is specially given in order to cancel the thing so that the result will come handy or easier. So you can write 22 by 7, or you can even finish up your solution with 1.4 pi. It's up to you. So 2 into 22 by 7 into 7 by 10. 0.7 is 7 by 10. 7 gets cancelled. This is 44 by 10, which is 4.4. 4.4 centimeter second is also the answer. The radius of a spherical soap bubble is increasing at the rate of 0.2 centimeter per second. Radius, sphere, rate of increase of the surface area. So we have to find out we have to know basically the surface area of the sphere, and the radius is given. At what point we have to find out? So we know that the surface area of the sphere is 4 pi r square. It's already given that the radius of the spherical soap bubble is increasing at the rate of 0.2 centimeter per second. So dr by dt is already given as 0.2 centimeter per second. So we have to find out the rate of increase of its surface area, ds by dt we have to compute, which is 4 pi. This r square is going to be 2r. There is no this t here, so we have to introduce dr by dt here. Dr by dt is already given as 0.2 centimeter per second. So this 4 into pi into 2, and at what radius? 7 centimeter given in the question. Just write it here. 4 pi into 2 into 7 into, there is 2 missing. Just remember 2 I have missed, into 0.2. When you compute, it is going to be 11.2 pi centimeter per second, but you can also compute it using pi as 22 by 7, because 22 by 7, 7 and 7 will get cancelled. A balloon which always remains spherical is being inflated by pumping a 900 cubic centimeters of a gas per second. Find the rate at which the radius of the balloon is increasing when the radius is 15 centimeter. Sphere, it's already given. There's a rate also given. Okay, 900. So this is the rate of how the balloon is getting inflated. Means the air is getting pumped up and the size is increasing. So this is volume you're talking about. Centimeter cube, that means volume. Centimeter square, that means some area. So the radius is given. At what point we have to find out? Is 15 centimeter. We already know the volume of the sphere, which is 4 by 3 pi r cube. We have already seen this. You need to know the volume, area, etc. dv by dt we are going to find out. 4 by 3 pi, this is going to be 3 r square. And for r, because we are differentiating with respect to t, it is going to be dr by dt. Dr by dt is already given. Oh, not. Because rate of at which the radius of the balloon is to be found out. So dr by dt is to be computed here. dv by dt is already given in the question, which is 900 centimeter cube per second. Alright, dv by dt is 900 centimeter cube per second, and 4 by 3 pi 3 into r square. R square is also given, means r is given 15. So 900 is equal to 4 by 3 into 3 into 15 into 15, which is going to be 225. And dr by dt. Dr by dt, in order to compute this, just take dr by dt on one side. All other things you just push it on the other side. So 900, 3 gets cancelled, 4 pi will come in the denominator, 15 square will come on also in the denominator. 15 square is 225, 225 into 4 is, I'll just compute it, okay? That is going to be 900 anyways. So we have 15 into 15, which is 5, 5, 25 by 75, 1, 5, 5, this is 12, 1, 225. This is 225. Into 4, you already know 225 is 450, 450 into 2 is 900. We already know, just for the sake of completion, because you need to show the examiner that I know this, I have computed this. On the right hand side, you can just find a small space to do all the computation. So this is the answer, okay? Please remember it is centimeter per second because we are finding the dr by dt. The radius of an air bubble is increasing at the rate of 0.5 centimeter per second. Dr by dt is provided to you. How did I get the idea? Because it is centimeter per second. From the unit I got the idea, it is talking about only dr by dt. At what rate is the volume of the bubble increasing when the radius is 1 centimeter? Volume is what? We're talking about a bubble, which is a sphere. Volume is 4 by 3 pi r cube dv by dt, which is going to be 4 by 3 pi 3. This is 3r square, and then dr by dt. So what we have to find out? This is dv by dt we have to find out. Dr by dt is already given, which is 0.5 centimeter per second. So 4 by 3 into pi. You can always replace this pi by 22 by 7. But normally we generally write in the form of, or with having a pi here. 3 gets cancelled. 4 pi, this is 0.5, which is going to be 2 pi centimeter cube per second, which is dv by dt, the rate of volume of bubble increasing when the radius is 1 centimeter. So dv by dt is your final answer. A man 2 meters high walks at a uniform speed of 5 km an hour away from a lamppost 6 meters high. Find the rate at which the length of his shadow increases. Now this question, I'm going to explain it in a very detailed manner, because many questions we are going to encounter in the same way. So let us make a diagram. Let me make you understand what we are trying to do here. So here is a person. The person or a man is 2 meter high. His height is 2 meters from the ground, and he walks away from the lamppost, which is 6 meters high. So just make the size should be thrice of the size of the man, because he is 2 meters high, the lamppost is 6 meters high, and he is going away on the right in this direction. It is going right on the right. Find the rate at which the length of his shadow increases. So we are going to use the similar triangle, and then because from the lamppost there will be a shadow. This is the height, just 2 meter. This is the height, which is 6 meter. We don't know this one, so it is x, and this we are going to use because he's going on to the right. He's moving away. We are going to use dx by dt for that. Y is the size or the length of the shadow. Similar triangle, I don't need to tell you because you already know it very well. So this is A, this is B, this is C, this is D, this is E. So we are talking about two triangles, which is the bigger triangle ABE and the second triangle, which is CDE. So just take this AB divided by CD is equal to AE divided by CE. So we are talking about two triangles, ABE and CDE, and these two triangles are similar. So the side corresponding have an equal ratio. So AB by CD is equal to AE by CE or EC. Now just have to replace the things which are given in this question. AB is 6, CD is 2, AE from here it is x plus y, CE is a y. Now this is 3, 3y is going to be x plus y, y comes on one side, it is going to be 2y equals x, or you can say x equals to 2y. We are interested in dy by dt. Remember, rate at which the shadow, length of his shadow increases. So we are interested in dy by dt. Differentiate both the sides. One of the thing is already given because the rate at which the man is moving away from the lamppost is already given as 5 km an hour. Alright. So dx by dt, because the distance of a man from the lamp we have taken as x. So we are going to write 5 for dx by dt, and dy by dt is what to be computed, which is the rate at which the length of his shadow increases or decreases. So dy by dt, just put it here, dx by dt 5, dy by dt is 5 by 2, which is 2.5 km an hour. Please remember, in these type of questions, the units are very important. If you don't write unit, then the marks will be deducted. It will be 2.5 km an hour. A stone is dropped into a quiet lake and waves move in circles at a speed of 4 cm per second. At the instance when the radius of the circular wave is 10 cm, how fast is the enclosed area increasing? This is a circle, or this is the formation of the waves. So it's a quiet lake. When you put some stone or make some movement, these are concentric circles. Waves always are found in concentric circles in this case. So the dr by dt, always in the radial direction, the waves moves away from the center. So dr by dt is already given as 4 cm per second. The radius, at what value we have to find out, the answer is 10 cm. How fast is the enclosed area increasing? Area is already known to us, which is pi r square. Area is pi r square. So let us differentiate this. For the reference, I am providing you the answer also. dA by dt we are interested in, which is going to be 2 pi r dr by dt, because pi, differentiation of r square is 2r. So 2 pi r dr by dt is 10. See, certain things are given here. dA by dt we have to find out. dr by dt is 10 cm per second, and at what radius? 4 cm radius we have to find. So in place of r, R, you are going to replace the proper value for dr by dt as 10. So it is going to be 80 pi centimeter square per second. This is your answer.